Hello and welcome to a new video. Today I will be improving my Android app even more. Just a bit of refactoring and improving the code because the app is fairly stable. For two models, it is using a bit too much memory. Two phone models. Let me show you right here. As you can see, these are the errors of the latest version of the app. 98% crash free, and most of this crash are my test devices. So yes, but still it has sometimes an out of memory errors. So it has to have memory leaks somewhere. That's my guess. That's why I have included Leak Canary, the library to analyze memory leaks. As you can see here, it says Leak Canary, watch an instance of whatever, and says here it says beginning of crash, but I cannot see anything related to that crash. So I will keep these open, but still haven't found the memory leak. So probably it gets triggered not very often because right now the app has more than 500 active users, and only 2 of those have experienced a memory leak. As you can see, only 2, one user here and one user here. So only 2 users out of 500, so less than 1%, like 0.25%. But still, if I can improve the app, I will always improve it, and I'll share the experience with you. Okay, so this thing is an out of memory errors. Okay, really, these I don't think what's going on here is these out of memory errors are different to are harder to track than a crash because the crash occurs at the specific line, and this log will tell you at what line the crash occurred. But that's not the same with memory. It shows us where the memory error appeared, but that may be a accumulation from previous memory. But here, what's actually most important is how many bytes it is trying to allocate here. It's trying to allocate 41 megabytes. That's too much, I think. That shouldn't be the case, right? However, it still has 13 free gigabytes. Oh, but I guess this is the 13th. Okay, so let's go and check appicon.kt at line 9. Okay, appicon.kt at line 9. So line 9 is this. Oh, pixels. Okay. So here we have something to think about actually. Because if it is trying to allocate that many bytes, well, that's not the same as many pixels, right? So let's do a quick math to see how much pixels should we be having. So it's roughly 42 million. Actually, not 40, yeah, almost 42 million. Okay, let's assume it's 42 million. So 42 megabytes, okay? But I want to know the number of pixels that's being created here. And I don't really know for sure, but Probably we can ask ChatGPT, but let me just set up ChatGPT a quick second. Okay, here in ChatGPT, we'll ask, still recording? Yes. How much, but does a ARGB pixel takes in Kotlin Android? I don't know. 4 bytes, yeah, I mean, 4 bytes. Okay, that's the reasonable thing. 1 byte for each one of this, which is okay, I would say. It's okay, it's acceptable. Right? And also, it is what it is, right? I cannot change that. What I can change is the number of them. So 42 million divided by 4, like, 10 million megabytes plus 4. I mean, 10.5 million pixels. Megapixels. So if this is trying to allocate 10 megapixels, that is maybe too big, right? Yes, I would say so. I don't know what kind of device is this Technocamon 20 or 2D or whatever, but I don't know why it's requesting or having such a big thing. I would like to see the resolution of this device. Let's try to search for it. Let's see. So this is the phone that's experiencing 1080 but by 2400. Okay, so it means it has 1080 in width. And 10 megabytes would be like the square root of this. If we assume this is a square icon, right? So it will be like 3.2 million? What? No. 3.2 million? Why too many? Why too much? Am I missing something? What is the average app icon size on a high screen resolution Android phone? I mean launcher icon in pixels. Something's wrong, for sure. 192 to 192. Can it be higher than 192? Yes, it's possible. I mean, imagine you have a 4K phone, right? What's 4K? I mean, 4,000. Okay, and you want to show like divided by 7. Okay, so even in a 4K screen, and if you divide it by 7, like 4K divided by 7, will get you 571. Okay, that times 571 would be 326,000, but not 10 million. Okay, so what I'll do here is we will check what we are doing here, and if the thing is too large, we have two places where we're calling this from. Let's see, what's the one place? It's this, and the other, where is the other? Why two places? I don't get it. Okay, so this is one. If pixels are null, are pixels different than pixel sizes? Okay, not my favorite, but and the other is init grid item. Well, this one is not the one that I'm searching for. This one is the one I'm searching for. But here we have something kind of odd. Because, I mean, I guess it has to be null, right? Okay. So here, or probably here, is where we should fix this. Drawable to bitmap. Here, I think, is what we should do. How to resize a drawable in Kotlin Android. Okay. Resize drawable. Okay, I have to create a bitmap. It just does set bounds and draw. Set bounds and draw. Yeah, that's correct. So here, it first checks if it's 0, then it puts it to 1. Otherwise, puts it to the whatever value it's here. Now, so here probably we should say drawable dot intrinsic width and ball height drawable dot intrinsic height. And here, this could be 0, right? So if it's 0, maybe we should do a min here, rather. Right? Whatever is less. But it cannot be 0. So probably what I should do is delete this. And here I should say min between have to import this. Double indent, I think int. So min between width and let's say max size, but what if it's not completely square? Factor. We will get the anyone, like width. We have to find the number in which we have to divide width by or multiply to make it less than max height. Max side size. And this would be, we want to be generous. So we'll do more than 192. We'll do, I don't know how much they increase really from step to step, but yeah. So 1 dot something. 192 divided by 144. 192 divided by 144. 1.333 times 192. 256. So that's our size. 256. Okay. So that's the maximum size of pixels that this thing will have. Because even if we do 256, times 256 because of the other side, that's the number of pixels, and 4 bytes per pixel, we get, did I do it correctly? Yes, 200,000 kilobytes, even with this size, which is nowhere near the 10 megabytes that I was getting there. But okay, so, yeah, I mean, the factor is like, I just want the factor if the largest side is larger than the max side size. Okay. So ball largest side, too much code, but okay, it would be max width, actually W and H. So here we will do if largest side is greater than max side, what we will do here is, if largest side is greater than that, we have to do resizing. So probably to do that, we have to put this a bar. Yes, I guess so. And here we have to reassign W and H. So we maybe here have to find a factor of largest side. Like, what's the factor to make it become 256? So, for example, if it's 512, so we have to divide it. So factor is largest side divided by max side size. And this has to be a float, right? Yeah, I guess. So W is divided by factor, and H is also divided by factor. So this is a transformation factor. Will using integers be enough? Well, yes, I guess. So will this code work? I don't know. Will these resize the bitmap? Will this approach make the icon stays the same visually, but only with a different size? Yes, please say yes. Not saying anything. Okay, I'll just run it. Okay. And apparently it works. Yeah, because even, let's say, like here you have 7, right? And then you increase the icon size. Yeah. I mean, it works. I think it works. This drawable created within bitmap width. However, depending on the reason of drawable, the desired dimension, the visual appearance of the drawable may change. If you want the drawable to maintain visual appearance, simply scale it to a different size. While simply scaling to different sizes here, This modification to drawable will be scaled to fit new dimensions while maintaining its original visual appearance as much as possible. However, it's important to note that scaled drawable shows some loss of quality, especially in dimensions significantly different. What I want to know is that if using the canvas method will not cut the icon. Oh. But I did this. This modified approach calculates the scaling factors to fit drawable within the dimensions while preserving the aspect ratio centered within the view. Response for ensuring the draw is greatly compared without any insertion of curve. Let's break it down. Then it calculates the largest size of the drawable checks and see the maximum size. If the larger size exceeds maximum size, calculate the scaling factor to resize drawable accordingly. He creates a new bitmap with the calculated width and height using create bitmap. It creates a canvas to draw the drawable onto the bitmap. It sets the bounds to the drawable on the canvas and draws the drawables onto the canvas. Finally, it returns the resulting bitmap. This function ensures that the drawable is converted to bitmap with a maximum size of 256 pixels while preserving its aspect ratio. If the drawable's target side exceeds this size, it is scaled down proportionally to fit within the maximum size limit. This helps maintain the visual integrity of the drawable without cutting off. Okay, I mean, as far as I can tell, it's okay. So, I mean, this this drawable to bitmap actually does some processing, right? So it does some processing there, and now it probably reduces the use of memory because it's not like allocating 10 megabytes when it should now will allocate at most 40 times less than that. 40 times less. So that's a big improvement. So leaks, oh, is this for Leak Canary? Cannot be opened as far as I can tell. Okay, so that's one way of doing this. We have made the thing smaller, which is what's causing here the crash with this Tecno Camon 20 device, which I haven't heard in my life, but okay, lots of devices in the internet. And we also have another one in a Moto G14, unable to allocate. This is less 700,000 bytes in location. Okay, and where is this? You need data, apps 91. Apps 91. Okay, apps 91. Probably these ones. Well, but I think with only that modification, I think we can reduce these memory leaks, these out of memory errors. I think so. I haven't slept very well last night, so I'm a bit sleepy and slow. So another thing that I wanted to do, I thought it may be a good idea but not sure, is that I was thinking in moving some of the data from the activity to the app object, because sometimes the activity gets recreated and that may cause the object to be recreated when that's not needed. So if I can maintain that on the app object, maybe that we can improve on that. What I would like to do though, since it's hard to move all the code, I would like to, I have the RO thing right here, and I would like to probably say, if we read something like we're doing here, I would like to know how big of a file am I running. Can I get the file size? Probably. So OL source size Hmm. Let's ask ChatGPT how to get the file size in Kotlin. File length. File that length. That length. Okay. Read file size. Actually, file name, file size should be. File name, file size. So what I wanted to hear is this is reading from disk to memory, right? To RAM. And we want to prevent out of memory errors, right? So if we know which are the largest files, we can optimize for that, right? File size. So as you can see right here, the obvious candidate is app icons list with 500,000 kilobytes. And it has how many apps? Like 7 times 2, 14, 15, 16, 17. So 538 divided by 17, 539, let's say. 539 divided by 17, 31 kilobytes. If we do a square root of this, should I divide it by 4? Divided by 4, that means the pixels in thousands. Is that correct? And that square root (2000 by 2000). No, I'm wrong. I don't know what I'm doing here. So 31 kilobytes per icon. Then 7,000 pixels in total. Oh, 7,926. Okay, so square root of 7,926. Oh, 89 times 89. So it's 89 pixels. Let's say. So 89 pixels is what we have here. 89 pixels. Yeah, I think it's okay. 89 pixels, right? Yeah, so let's say the app gets restarted so many times that this becomes a memory problem. I don't think so, but let's imagine. Maybe we are running in a very low-end device. So for that, we will probably, well, not sure on how to do this right now because it's not that easy. Yeah, but app icons map, it's called. Now I maybe can move this guy to the app thing. Yeah, maybe, maybe that's not a great idea, right? Who knows? Maybe we should move the bitmaps as well. This bitmap right here. So actually, as far as I can tell, these two variables are probably what are causing the out of memory errors. More likely. No. So this one is read from the disk, and this one is constructed for fast access of bitmaps, so I don't have to be constructing bitmaps every time. As you can see, and here I can access this. I don't know where from the adapter should I be accessing it, right? I don't know really, because I mean, I'm not accessing this. Oh yeah, creating the item. Oh yeah, I'm accessing it. Okay, so I think I will be testing this build, let's say, for a couple of days. Maybe we'll improve it later a bit more. But hopefully, with these changes I just made, those memory errors get fixed. I hope that. And I think I will go to sleep really because I'm slow and tired. I'll just move it to my phone, to my personal phone, to test it here. Okay, so run. It's building the release version this time. This video was shorter, I think, because I'm tired. Actually, not that short. It has been 38 minutes. So, this has been it for this video. Thank you for watching. I hope you like it. Leave a like, and I see you on the next one. Bye.